Hello, in this class we will introduce the game theory. We will cover some basic terms and the principle of max min minimax. First of all, game theory. It is a kind of decision theory in which one's choice of action is determined after taking into account all possible alternatives available to an opponent playing the same game. Okay. J. von Neumann is known as the father of game theory. He has given the principle of max min minimax in game theory. What is a game? A game is a competitive situation. Okay. A competitive situation is called a game if it has following properties. What are the properties? Number one, there are a finite number of competitors called players. Number two, each player has a finite number of strategies or alternatives available to him. Three, a play of the game takes place when each player employs his strategy. Four, every game results in an outcome. For example, loss or gain or a draw, usually called payoff to some player. Now, two-person zero-sum game. When there are two players playing the game, it is called a two-person game. If the algebraic sum of the gains and losses of all the players is zero, such games are called zero-sum games. Zero-sum games with two players are called two-person zero-sum games. In such games, the loss or gain of one player is exactly equal to the gain or loss of the other. If the sum of gains or losses is not equal to zero, then the game is called non-zero sum game. Now coming to strategy. What is strategy? Strategy is nothing but a set of rules or alternative courses of action available to a player in advance. Pure strategy. If the players select the same strategy each time, then it is called pure strategy. In this case, each player knows exactly what the other player is going to do. A deterministic situation is obtained. The objective of players is to maximize gains or minimize losses. Now, mixed strategy. When the players use a combination of strategies and each player always keeps on guessing as to which course of action is to be selected by the other player at a particular occasion, then it is known as mixed strategy. A probabilistic situation is obtained. The objective of player is to maximize expected gains or to minimize losses. Value of the game. It is the expected payoff of the play when all the players of the game follow their optimum strategies. Payoff matrix or payoff matrix to player A. Okay, player A and player B. So let A1, A2 and AM be the strategies of player A and B1, B2, BM be the strategies of player B. Then the payoff matrix is given like this, where A11, A12, A1N and so on AMN are respective payoffs related with the pair of strategies chosen by both the players. For example, let me consider A11. So A11 is the payoff to player A when player A chooses A1 and player B chooses B1 strategy. Okay. So the let player A has M strategies A1, A2, AM and player B has N strategies B1, B2, Bn let Aij be the payoff which player A gains from player B if player A chooses strategy AI and player B chooses strategy BJ. In case of zero-sum game, each entry in the player B's payoff matrix will be negative to that of corresponding entry Aij in the player A's payoff matrix. Okay, so this is by definition of zero-sum games. Maximin minimax principle. Okay, in the payoff matrix to player A, the minimum value in each row represents the least gain to him if he chooses his particular strategy. He will then select the strategy that maximizes his minimum gains. This choice of player A is called maximin principle, and the corresponding gain is called the maximin value of the game. For player B, the maximum value in each column represents the maximum loss to him if he chooses his particular strategy. He will then select the strategy that minimizes his maximum losses. This choice of player B is called minimax principle, and the corresponding loss is called the minimax value of the game. If the maximin value equals the minimax value, then the game is said to have a saddle point, and the corresponding strategies are called optimal strategies. The amount of payoff at the saddle point is known as the value of the game. Okay, so this is the principle, maximin minimax principle. Now let's try to understand it with the help of an example. So let's consider a payoff matrix to player A. Okay, A is having 4 strategies, B is also having 4 strategies. Okay, now let's talk about player A first. Okay, so the minimum value in each row, right? So what is the minimum value in first row? That is 4. Second row it is 1. Third row it is 4. Fourth row it is 6. So these minimum values in each row represent the minimum gain to player A for strategies of player B. Now his objective is to maximize his minimum gain, that is maximize these row minima. Okay, this is maximin principle. Secondly, player B, okay, the maximum value in each column represents the maximum loss to player B. That's quite right. For example, suppose this, take this value 10. This 10 is the profit to player A, and minus 10, okay, it will be minus 10 value payoff to player B, that is loss of 10 units, right? So maximum loss to player B pertaining to strategy B3 would be 10. So hence these maximum values in each column are the maximum losses to player B. Now his objective would be to minimize his maximum loss. So that is minimize these values, column maximum. And if we see, that is 6 here, minimum in all these and maximum in all these also 6. So this 6 and 6, if we consider, so this is the point of intersection here. This place, okay, this cell, okay, or this position represents this value where maximin is equal to minimax. So this position is called the saddle point of the game, and the value lying at this is value of the game, and the strategies corresponding to this position, that is A4 and B1, these are the optimal strategies to player A and B respectively. So maximin it is 6, minimax it is 6. Since maximum and minimax is equal to 6, the game has a saddle point. The saddle point is the position 4, 1 corresponding to strategies A4 and B1, and the value of the game is 6. So this is how we can understand the principle of this maximin minimax principle. Another question, find the ranges of P and Q which will render the strategy entry 2 as a saddle point for the game. This is the payoff matrix to player A. It's a solution. So considering this, now ignoring the values of P and Q, finding the row minima and column maxima, just like this. So these are the row minima. Here 2 is minimum, here 7 is minimum, here 4 is minimum, and similarly 10 is maximum, 7 is maximum, and 6 is maximum. So take the maximum value of row minima. So this maximum of this is 7 and minimax is again 7. Now this 7 would be the value of the game. So entry 2 to be the saddle point, Q should be greater than 7 and P should be less than 7. Let us see back. This Q should be less than 7, because if it is more than 7 then it will not be here. So this entry 2 will not be saddle point. And if then the P should be, no sorry, Q should be greater than 7, and okay, only in that case 7 is the minimum in this row, and P should be greater than P should be less than 7, only then 7 is maximum in this column. Okay, so these are the ranges in order this entry 2 to be the saddle point. Thank you very much.